While the world marveled at bridges and skyscrapers, Japan quietly did the unthinkable. It built a tunnel beneath the ocean that defied earthquakes, outlasted typhoons, and stunned billions. Hit that subscribe button before we continue on how Japan went under the ocean and built the impossible. Across the globe, engineers have tested the limits of what's possible, striving to defy the natural world and reshape the landscape. But in Japan, a nation shaped by the sea and forged by innovation, one underwater tunnel project has stunned the world with its audacity, technical brilliance, and unyielding precision. At the heart of this visionary endeavor lies the ambition to connect islands, not with ferries, not with bridges, but with a permanent artery beneath the ocean itself. The idea was simple in its conception yet monumental in its execution. A tunnel that would span beneath the waves, allowing people and goods to traverse the ocean floor safely and seamlessly. This project is not just about connecting islands, it's about crafting a legacy, one that would endure the forces of nature and become a symbol of mankind's unwavering will to push the boundaries of possibility. This is unbelievable, but this ambition became a reality with the Saikan Tunnel, which connects the islands of Honshu and Hokkaido. Stretching over 53 kilometers, with 23.3 kilometers of it running beneath the seabed, the Saikan Tunnel was a groundbreaking achievement that stunned the world with its engineering precision and resilience. The tunnel was built to withstand the seismic activities in the region in severe weather conditions, including typhoons, challenges that were carefully planned throughout its design and construction. Construction of this marvel did not begin with the familiar steel and concrete that often dominates monumental projects. No, this tunnel's foundation was forged in the unseen and uncharted depths of the ocean. The first step was not a matter of physical construction, but of understanding the very environment where this tunnel would rise from the ocean floor. Engineers and marine scientists embarked on an exhaustive campaign of surveying, utilizing advanced sonar systems, unmanned aerial drones, and state-of-the-art deep-sea robots. Together, these tools mapped the ocean floor in intricate detail, capturing every nuance of the seabed, every rock formation, every current, every sediment layer. The task was far from easy. The seabed, once mysterious and untamed, had to be transformed into a meticulously studied blueprint. It was only through the seamless integration of cutting-edge technology and years of research that the engineers could pinpoint the exact locations for the tunnel's foundations. This process of mapping the ocean floor was painstaking, but it laid the groundwork for what would become one of the most daring feats of engineering history. Then came the first daring and bold move in this unprecedented project, laying the foundations on the seabed. The procedure, though seemingly simple, was a monumental task requiring flawless execution and a deep understanding of the forces at play beneath the waves. The engineers used massive barges to transport prefabricated tunnel segments, each one a work of art in its own right, designed not just for strength but for stability in the harsh underwater environment. Once the tunnel segments were ready, they were carefully lowered by cranes with laser-guided precision. The deployment was orchestrated by a team of expert divers, working in tandem with cutting-edge systems and high-tech laser equipment. They guided the heavy segments as they descended toward the ocean floor, ensuring that each one was placed with millimeter precision. It wasn't just about getting the segments in place, it was about perfecting the alignment, ensuring that the entire tunnel would sit flush with the foundations, ready to withstand the immense pressure of the surrounding ocean. The operation was nothing short of a spectacle. From above, the barges appeared as colossal creatures, slowly sinking beneath the surface with tunnel segments hanging from their massive hooks. Below, the divers swam gracefully alongside, their movements deliberate, each one of them part of an intricate choreography of precision. Every piece of machinery, every human action, worked in harmony as the world watched in awe. This was the moment where the ocean ceased to be an obstacle and became the very foundation of human innovation. Through tireless teamwork and unwavering precision, the foundations were set, each tunnel segment perfectly aligned on reinforced platforms at the bottom of the sea. What had once been an alien landscape of shifting sand and rocky outcrops was now a carefully controlled and methodically arranged base for a tunnel that would span the ocean's depths for decades to come. As Japan's Saikan Tunnel proved, the foundation of such an engineering marvel had to be carefully laid out to endure the rugged and unpredictable nature of the ocean. The construction began with the installation of the tunnel's tunnel boring machine, which worked tirelessly through the hard rock and sandy seabed. The tunnel segments were prefabricated and then transported by rail to the tunneling site, where each segment was carefully aligned and assembled. As the pieces of the tunnel were submerged and aligned, engineers applied a meticulous process to ensure the structure's endurance over time. Waterproof seals, made from advanced synthetic materials, were placed at the joints where each section met. These seals formed an impermeable barrier, designed not only to withstand the corrosive salt water that relentlessly batters the ocean floor, but also to guard against the crushing pressures that build up deep beneath the waves. The next layer of protection came in the form of corrosion-resistant concrete, specially engineered to endure constant exposure to the sea's volatile elements. This concrete wasn't just any ordinary mixture, it was a sophisticated blend of polymers and silica formulated to ensure longevity and resilience against the powerful forces of nature. The concrete was applied in layers, enveloping the tunnel's structure like armor, preserving its integrity for decades to come. With each application, the material bonded with the underlying surface, creating a seamless, unified shield. But a tunnel is not just a structure, it is a vital lifeline. A symbol of progress and innovation that carries with it the promise of connection and convenience for future generations. Beyond its sturdy exterior, the tunnel is a living, breathing system designed to stand the test of time. Once the external structure was in place, the focus shifted inward. Inside the sealed shell, engineers meticulously installed the systems necessary to make the funnel a fully functional passageway for vehicles and passengers. These weren't mere pipes and wires. They were intricate veins and arteries of the tunnel, ensuring its smooth operation for years to come. State-of-the-art lighting systems were installed, providing illumination throughout the tunnel to guide travelers through its depths. The lighting was not only functional, but strategically designed to create an environment that would be both welcoming and practical. A crucial part of this tunnel's design was its ability to react and adapt to changing conditions. Engineers installed a network of redundant sensors, each one designed to monitor a different aspect of the tunnel's operations. These sensors tracked air quality, ensuring that the tunnel maintained breathable conditions. They also monitored water leakage, detecting even the smallest breaches in the waterproof barriers. Structural integrity was continuously assessed by sensors embedded within the concrete, which provided real-time data to engineers monitoring the tunnel's performance. Additional sensors tracked vehicle flow, ensuring that the tunnel could accommodate the growing demands of future transportation without compromising safety or efficiency. The tunnel was more than a mere passage. It was an intelligent, self-regulating environment that anticipated needs and responded to challenges before they could become problems. No great feat of engineering is complete without rigorous testing, and this tunnel was no exception. The final test was as ambitious as the project itself. Simulated earthquakes, generated by applying external pressure at varying intensities, were used to evaluate the tunnel's ability to withstand seismic activity. It wasn't enough to simply build a tunnel that could survive under normal conditions. This tunnel had to be capable of withstanding the worst that nature could throw at it. As the tremors coursed through the tunnel, the structure flexed, bending and shifting under the pressure, but never breaking. It responded with the quiet resilience of a living organism adapting to the forces around it. The structure held firm, its joints and seals remaining intact as it absorbed the shocks with ease. It was a testament to the tunnel's design and durability, proof that it could withstand the unpredictable nature of the ocean and the powerful forces of the Earth's crust. When the final test was complete, the results were conclusive. The tunnel had passed every challenge with flying colors. It was more than just a structure of stone and steel. It was a modern marvel, capable of withstanding the test of time, natural disasters, and the ever-evolving needs of future transportation. This tunnel is not just a passageway for cars and trucks. It is a symbol of Japan's forward-thinking vision for the future. It represents the nation's ambition to connect islands and people across the vast expanse of the Pacific Ocean, creating a seamless flow of both goods and ideas. More than a feat of engineering, it reflects Japan's commitment to overcoming the natural challenges posed by its geography, its archipelagic structure, and susceptibility to seismic activity. But to withstand earthquakes, typhoons, and the test of time itself, this tunnel stands as a testament to Japan's resilience in the face of nature's unpredictable forces. Climate change has accelerated the need for more sustainable, adaptable infrastructure. The tunnel serves as both a practical solution to an ever-expanding transportation network and a visionary answer to the future of urban mobility in a world increasingly defined by environmental challenges. What was once regarded as an impossible dream is now a thriving artery of movement. Beneath the waves, it hums with life, a metaphor for Japan's persistent drive to innovate, redefine the limits of possibility, and position itself at the forefront of the global engineering landscape. This tunnel does more than connect two distant points. It intertwines the destinies of Japan's islands, fosters economic growth, and embodies a harmonious balance between technology and nature. It is quite literally a beacon of modern Japan, guiding the nation toward a future that is both sustainable and interconnected. Japan's underwater tunnel is merely one chapter in the country's rich legacy of engineering marvels. The same ingenuity that made this tunnel a reality can be seen in Japan's mastery of other large-scale projects, from the breathtaking bridges that span its storm-swept bays to the dams that tame the fierce rivers cutting through its mountains. These structures speak to a nation that has long understood the necessity of turning geographic adversity into architectural triumph. Consider, for instance, Japan's innovative approach to dam construction, a process that mirrors the ingenuity required for its underwater tunnel. Before a dam can be built, the force of nature must be diverted. Temporary barriers are strategically placed to control the flow of turbulent rivers, creating a dry foundation for the construction of the dam. Workers then carve out stable, solid ground, carefully laying the groundwork for what will become a massive, indomitable structure. The dam's body begins to take shape with the placement of massive concrete blocks, each one meticulously designed to withstand the unimaginable pressure of thousands of tons of water. These blocks are lowered into place with precision, aligning perfectly to form a seamless, enduring structure that stands as both an engineering marvel and a safeguard for surrounding communities. Once complete, the dam is transformed into a source of power. Turbines and drainage systems are installed to harness the energy of the flowing water, turning what was once a barrier into a powerhouse of clean, renewable energy. This transformation of nature into infrastructure is more than just a construction process. It's a reflection of Japan's relationship with its environment. The nation has continually sought to work with, rather than against, the forces of nature, creating systems that are as resilient as they are functional. Whether it's the massive concrete pillars of a bridge that sways gracefully with the winds, or the tunnel that resists the shifting tectonic plates beneath the ocean, Japan's engineering feats serve as a reminder of what can be achieved when human innovation meets nature's challenges head-on. Through projects like these, Japan has proven time and again that even in the face of the harshest geographical conditions, engineering excellence can not only survive, it can thrive. Modern bridges in Japan are no less extraordinary. Deep in the seabed, foundation piles are driven with seismic isolation systems built in. Towering piers rise next, followed by steel beams and tension cables, laid with help from robotic cranes. Each bridge is an exercise in balance, distributing wind, water, and weight into a fluid aerodynamic whole. Also, inland Japan's rail construction exemplifies speed and accuracy. Machines now lay track with near total automation. Rails are positioned, fastened, and secured with laser-guided precision, reducing labor costs and increasing safety. These systems have turned weeks of work into hours and have become global benchmarks in transportation. River projects too are approached with harmony in mind. Water is temporarily diverted, foundations are set, and reinforced structures guide the flow with sensors and automation keeping constant watch. Roads follow a similar path. Sublayers are compacted, asphalt is poured and rolled, and safety infrastructure is added, all using environmentally considerate technologies. Even the coastal edges of Japan are shaped with care. Seawalls built from precisely arranged boulders and covered in reinforced concrete act as shields against tsunamis and erosion. Each stone is placed at a specific angle to absorb and scatter wave energy. It is not just engineering, it is protection in physical form. Japan's engineering community is not only shaping the skyline with towering structures and breathtaking bridges, but is also at the forefront of eco-friendly and rapid construction methods that are transforming how we think about building the future. Their innovations blend tradition with technology, pushing boundaries while considering the environmental impact. One such breakthrough is the use of modular concrete blocks. These blocks, designed to interlock seamlessly without the need for mortar, represent a significant departure from conventional construction. They reduce construction time, minimize waste, and eliminate the reliance on harsh chemical adhesives, making them not only efficient but environmentally responsible. However, no project epitomizes Japan's engineering prowess quite like the Saikan tunnels. Once deemed an impossible dream, the concept of constructing tunnels that connect islands through the deep, unpredictable ocean rock has been brought to life through relentless innovation. The project is a monumental achievement in civil engineering, overcoming the staggering challenges posed by underwater construction. These tunnels are not simply passages through the sea, they are symbols of human resilience and ingenuity. Engineers face the daunting task of navigating through layers of ocean rock with unpredictable pressures and constant exposure to the relentless forces of nature. The construction process itself involves a staggering level of precision and foresight. Workers must contend with the ever-present threat of seismic activity, unpredictable currents, and the immense pressure of the water above. Yet, through cutting-edge technology, they have been able to build tunnels that can withstand these challenges and function for decades without compromising safety or stability. The tunneling process relies on sophisticated machinery that can cut through rock while minimizing environmental impact, and the use of reinforced, pressure-resistant materials ensures the durability of the structure. What are your thoughts on undertaking such monumental projects that push the boundaries of what's possible? Share your thoughts in the comments. Thank you for watching this video with us, and catch you in the next one.